I'm Vs.Holtzman of Holtzman Engineering. I'd like to discuss bowling ball imbalance and our new Holtzman ball scale versus the Kaufman scale. I started bowling about 3 years ago, and I had several balls drilled, and I watched my driller use this Kaufman scale to get the balance. And I've been an inventor most of my life, and I looked at this scale and I thought, I think I can make something that would do the job, maybe less expensive, maybe a little more accurately, and certainly faster. So I started working on a scale, and my mind kept telling me that I didn't have enough information. Just something was always lingering in the back of my mind. And let me give you an example what might show you my dilemma. Let's just assume this ball here is perfectly spherical, uniform in density. It has no weight imbalance. And then we have a half-inch hole. We're going to drill a half-inch hole, horizontal hole through the center of the ball, and this half-inch hole lines up with the axis of the Kaufman scale. Okay, the ball still has no weight imbalance left to right here. So then let's take a half-inch dowel pin that happens to weigh an ounce, and we're going to put it in the half-inch hole just so it lies just at the surface of the ball. And then we're going to balance the Kaufman scale. Okay, then what's going to happen if I start moving the dowel pin this way? And let's say if we move it right to the center of the ball, but it still lies in this hemisphere like it did before. Okay, by definition, this hemisphere still is 1 ounce heavier than that hemisphere. But as I move that dowel pin that way, what's going to happen to the Kaufman scale? It's going to tip up. It's going to do this. So basically, with this hemisphere, both hemispheres are 1 ounce heavier. This hemisphere is still 1 ounce heavier in both instances, but this Kaufman scale is going to give me two different readings. So that means that the specification is a bit arbitrary. It's not defined well enough. So then what I realized was that what we're actually measuring here in these scales, whether it's our scale or the Kaufman scale, is what is the torque that this ball is exerting due to the weight imbalance. And a torque, of course, is a force times a moment arm. And what I need, the force is the ounce, but what I needed to find out was the moment arm. Well, I went through some calculations of what is going on with this Kaufman scale. I had this whole page of formulas, and I did all the machinations on these formulas, and I got to the bottom, and all I had was a simple little, beautiful little formula, and I had to find out get two measurements off a Kaufman scale. So I bought this Kaufman scale used for about $700. If anybody's interested, I'll be selling it if I can shortly. But anyway, I got my measurements off the Kaufman scale, did my calculations, and then also I had found earlier a reference in some old literature to this torque, and I had a moment arm from that old literature. And when I did my calculations, my number agreed with this old number I found in this old literature to about 3 significant figures. So I felt like I had a pretty good handle on the moment arm that is used in this scale here. So then once I had determined the moment arm, I started designing my own scale. Well, this scale has evolved. It started out, it was longer than the Kaufman scale, and now it's about a third the length. And the other thing that I realized was that I don't really have to use this moment arm that the Kaufman scale uses. And if I, say, take my moment arm as a factor of 2 less, that I will decrease the inaccuracy of my product by a factor of 2, or I'm going to improve the accuracy by a factor of 2. And some people say, well, you can't do that. And I say, well, you can. If you want a quart of milk, I mean, a guy can give you a quart of milk in a quart jar, or he can give you a quart of milk in 2 pint jars. It's still a quart of milk. And so what we're using pints and they're using quarts. And all you got to remember is that if you get whatever weight imbalance you get with our scale, you divide that number by 2, and that's what you'll get with the Kaufman. So if you get 2 ounces of weight imbalance using our scale, you put that ball in the Kaufman with the same orientations, and you'll get 1 ounce within the accuracy of the scales. So I hope that clears some of the confusion up, and appreciate your time.